Okay, welcome to the solution video for the third problem, which is the halting problem. This, of course, is an allusion to the famous halting problem, which was proved unsolvable by Charles Babbage. But obviously, since the actual halting problem was unsolvable, this is completely different. So in this problem, you have cars, which are Turing machines. They're Turing complete driving machines. But basically they're cars, and they have to go to an intersection, and when one car is in the intersection, no other car will enter the intersection until the first one leaves. And there's also a note that if one machine enters, or if one car enters or reaches the intersection at the same time another leaves, it doesn't halt, it just keeps going. So there are two main solutions to solving this problem. The input was small enough that either of them would work, but I felt that the more efficient solution was actually easier to implement. So that's what we're going to do. And for the input, you're given the number of test cases. You're given how many driving machines there are for each test case, or in the first test case, and then how many seconds each driving machine takes to cross in the first test case. So we'll go ahead and implement that. Again, all of these problems are available on my website, which is in the link in the description if you want to look at them yourself. So we want a new class with main, and the first thing we're going to need is a scanner. Then we get the number of test cases. Test case is a word you can type exclusively with your left hand. Alright, and then for each test case, we get n and s. So int number of cars test.next int seconds cross. And then so I'm going to store all of the arrival times in an int array, and you'll see why really soon. But first we're going to read them all in. So we're going to read in I integers up to the number of cars, and each one we're going to store in the array. And then, since the cars aren't necessarily given in chronological order, I'm going to sort them just so we have them in order, and then we can work on that assumption, I guess. So we can use the arrays.sort method to sort it for us, which is pretty nice. Oh, I missed an S. Okay. And then what we want to do is, since each car or each identical driving machine takes the same number of seconds to cross the intersection, all we have to do is check if the difference between two adjacent elements in the array is less than seconds to cross. If it's equal to seconds to cross, for example, if it takes 3 seconds to cross, and one machine arrives at 4 and one arrives at 1, then the one with 1 leaves at the same time the 4 enters, so that's not an issue. So we have to watch out for off by 1 errors there, but if we just do less than, we should be good. So do 4 and I is 1, I is less than I plus. So we're starting at 1 because we're comparing the index at I to the index before it. You could also start at 0 and go to arrival times.length minus 1, exclusive obviously. And then I'm going to say if so if this one, minus the one before it, is less than seconds to cross, that means that the second one, the one at index I, would have to wait for the previous one. So if that's the case, we want to suss out yes. If we go through this entire for loop and it's not the case, we want to print no. And now if we do print yes, then we want to be done. So the way I'm going to do that is I'm going to put this for loop, the outer for loop, and then we're going to continue outer to the next test case. So if we ever enter this if statement, we'll print yes, and then we'll go back here. We'll go to the next test case, and test cases will implement or increment, and we'll just keep going from there. If we manage to get to this entire for loop without ever going into this if statement, then that means there were no collisions, so no cars will have to halt. So that was the intended solution. The other possible solution was to do two for loops, two nested for loops, this array, and you could basically check this with each possible index. The one exception to that is you'd have to make sure that the two indexes weren't the same, because then obviously you would have a collision. So you have to watch out for that. So that was the intended solution for the halting problem. That was the third problem. Congratulations to everyone who got it. This is where things start to get a bit more tricky. And after this, we'll look at the much harder problems where efficiency started to become a concern. So thank you for watching.